G'day, Mr. Hannah here. Did a bit of a hack of a video last time, so I'm doing a bit of extra here. Now what we're looking at is the average rate versus instantaneous rate of change. If you can hear the sound of drums, that's because my housemate is hitting them downstairs, so enjoy that backing track, if you will. Okay, so instantaneous rate of change versus rate of change. Now, first I want to just show you this little scenario. It's a guy standing on a cliff and there's a hot air balloon he can see floating away in the distance. And he's just graphing how high it is over at different periods of time. So let's have a little look. There it goes, it's floating away. You can see where it's at, depending on the time. Interesting situation. Okay, there we go. Now, what we want to discuss is the rate at which it goes up and down. Okay, the rate of change of the height of this air balloon. So what we thought about last time was the rate of change. The rate is actually given by the gradient of a line. Okay, so let's check that out. So there's sort of two types of rate of change that we can talk about. We can talk about average or instantaneous. So let's consider this situation over here where the balloon started from this point here and then it's moved to this second height here. Okay, so the gradient here, you can see if we can think about the average gradient or the instantaneous gradient. Now first off, let's think about the average gradient. So the average gradient, well, it's going to be whatever this height is, height 2, take away whatever this height is, height 1. So the difference between these 2 points here. So it's going to be h2 take away h1 divided by this change in time. So that would be time 2 take away time 1. Time 2 take away time 1. And then you can just put your values in. Now we can see that has happened down here. The average rate of ascent is the change in height over the change in time. So h2 minus h1, that's what we've done. Divided by time 2 over time minus time 1. Put the values in. So like the height 1 will be 50, the time 1 will be whatever that is, like 17 take away about 6 or something like that. And here we go, we've got 3.13 feet per minute. So we can show that average height. What really happened there was we drew this linear line from between these 2 points. Okay. Now this line, because it cuts through our curve, so it's got a special name. It's called a secant line, because it cuts through the curve. It doesn't sit above it or anything like that. And we do that sort of a line like that, a linear line, to give ourselves an average rate, because that'll give us the average gradient on this bit here. So you can see some bits are really steep, like here, some bits are going back down, like over there, and some bits are less steep. So that's giving us an average gradient. Now, we might want to know the exact rate, or the instantaneous rate at a particular point in time. So, for example, this point here, at first height, we want to know the instantaneous rate there. But what we can do is we can draw a tangent line. So this is what we call a tangent line. Here we go, tangent to the graph. And this is the tangent at this particular point in time here, which is around about like 6 minutes or whatever. Okay, so at this particular point in time, the tangent line, you see, it touches the graph. So right at that point, our tangent line has the same gradient. So this tangent line has the same gradient at that point. Gradient at that point. At that point. There we go. And so it looks like that. Now if I was going to draw a tangent line at, say, this other point, it would look more like this. Come through, go through that point, and go off the same gradient. Or if I wanted to do a tangent line at this point here, it would come up, touch it at the same gradient. Or one at this point here, this point here would come along, touch it, and keep going. So bad drawing. So these are all tangent lines. Now to find the instantaneous rate at this point, you get your tangent line drawn in, and then you find your gradient of the tangent line. So for instantaneous, rate, key is to draw a tangent, and then you've just got to find gradient of the tangent. Gradient of tangent. There we go. Whereas before, for average rate, key is to draw a line between 2 points, and then find the gradient of that line. Of the line. There we go. Awesome. Now, so that's the key piece of knowledge that that we need to really know. But there's one last thing, which is a formulaic way to know your average rate, which we touched on last time, but I thought I'd go over it to be more clear. So to find, with your average line, to find the gradient of your average line, it's the two y-axis bits divided by the change in your x-axis bits. Now, if you've got an equation that describes your line, and let's say your equation is called f of x, okay? So that's your equation that describes your curve. Then what you can actually do is find, let's say that this point here is like x1, the first x point, and this one is x2. What that means is, to find this height here, well, that's your function of x1. Okay, you put the value of x1 into your function, you'll find it. And for h2, that's f of x2. So to get the distance between f of x2 and f of x1, you just do a subtraction. So we could say the gradient is given by f x2 minus f of x1, and then divided by x2 minus x1. So that bottom bit, x2 minus x1, that is this distance here. Okay, so there's a formula way to actually find the gradient, which is kind of handy actually. But we'll come more to that later on. So best of luck with your textbook questions, and I'll see you in class.